Right now you are certain of one thing. You are moving through time. The seconds are passing. This sentence began a moment ago, and that moment is gone, and the next moment is rushing toward you whether you want it or not. You can feel it. It is the most obvious feature of being alive. The past is behind you, locked and unreachable. The future is ahead, waiting, unknown. And you, the person hearing these words, are a small bright point sliding forward along a line you cannot stop or reverse. This is the most intimate fact of your existence. It is also, according to a growing number of physicists, a hallucination, not a metaphor, not a poetic flourish about how time flies when you're happy. A literal hallucination, in the sense that the river you feel yourself standing in does not appear anywhere in the fundamental equations that describe the universe. When physicists go down to the deepest layer they have ever reached, the layer where general relativity meets quantum mechanics, the variable for time simply vanishes. It is not small, it is not approximate, it is not there at all. For most of the 20th century, this was a quiet embarrassment, a technical curiosity locked inside a few obscure papers. But over the last 20 years, three of the most respected theoretical physicists alive have looked at the same evidence and arrived at the same unbearable conclusion. Time, the thing you are using to listen to this sentence, may be a story your brain is telling itself to make sense of something that is not actually a story at all. What that means for you, for everyone you have ever loved, for every moment you thought you had lost, we will get there. But first we have to understand how an entire field of science quietly stopped believing in the river. Start with what you were taught. Newton gave us a clean picture of time. He called it absolute and described it as flowing equably, by itself, from its own nature, regardless of anything in the universe. Time was a backdrop. The cosmos was a stage, and time was the steady tick of a clock somewhere offstage that everyone, everywhere, agreed on. A second on Earth was a second on the Moon, was a second at the edge of a galaxy. This was common sense made into physics, and it held for 220 years. Then in 1905, a clerk in a Swiss patent office took the clock off the wall. Einstein's special relativity showed that time runs differently depending on how fast you're moving. A clock on a jet flying around the Earth ticks measurably slower than a clock sitting on the runway. This is not a thought experiment. It has been confirmed by atomic clocks placed on commercial aircraft. 10 years later, his general relativity made it worse. Time also runs slower in stronger gravity. The clock in the basement of a tall building ticks slightly slower than the one on the roof because the basement is closer to the Earth's center of mass. Your head is older than your feet by a tiny measurable amount. These are not philosophical claims. The global positioning system above you right now would drift by about 10 kilometers per day if engineers did not constantly correct for the fact that time on those satellites runs faster than time on the ground. Your phone finds you because Einstein was right. But notice what has already happened. The universal clock is gone. There is no single time that everyone agrees on. There is your time, and my time, and the time on a satellite, and the time at the bottom of a black hole. They are not the same, they never were. We just lived our lives slowly enough and close enough to sea level that we never noticed. This was the first crack. The second one came from somewhere stranger. In quantum mechanics, the equations that describe what an electron is doing make no distinction between past and future. Run the math forward, run it backward, the physics looks the same. Almost every fundamental law we have, from Newton's mechanics to Maxwell's electromagnetism to the Schrödinger equation, is what physicists call time-symmetric. The arrow of time, the thing that makes a broken cup not reassemble itself on the floor, does not appear in the laws. It appears only in the statistics of huge numbers of particles. It is, even in standard physics, already half a fiction. Then in 1967, two physicists named Bryce DeWitt and John Wheeler tried to do something nobody had managed before. They tried to write down a single equation that combined Einstein's gravity with quantum mechanics. They wanted the equation that would describe the entire universe at the deepest possible level. What they got back broke them. The Wheeler-DeWitt equation describes the quantum state of the cosmos. It is mathematically clean. It is taken seriously enough that 58 years later physicists are still building careers on its consequences. And it has one feature that nobody knew what to do with. It contains no time variable. You heard that correctly. The equation that describes the entire universe at its most fundamental level does not have a T in it. There is no flow, there is no ticking, there is no before and after. The universe, written in this language, does not evolve. It simply is. Wheeler himself, who coined the phrase black hole, called this the problem of time and admitted it might be the deepest puzzle in physics. DeWitt spent the rest of his life trying to interpret what they had found. Some physicists assumed it was a sign the equation was wrong. Others, including a young Italian theorist named Carlo Rovelli, began to suspect it was telling us something we did not want to hear. Rovelli is one of the founders of loop quantum gravity, one of the two main candidates for a theory of everything. In his 2017 book, The Order of Time, he laid out an argument that has slowly worked its way from the fringe to the center of theoretical physics. His claim is this: time is not a fundamental feature of reality. It is an emergent statistical effect. It exists for us only because we are large, warm, ignorant creatures looking at the universe through a thermodynamic blur. Imagine you are standing in front of a glass of water. There are roughly 10 to the 25th molecules in that glass. You will never know the position and momentum of each one. You can't. There is too much information. So your brain compresses the situation into a single variable: temperature. Temperature is not a thing in the water. It is a summary of your ignorance about the water. If you could see every molecule, you would not need the concept at all. You would see only motion. Rovelli argues that time is exactly this kind of variable. It is what you get when you take a universe that has no fundamental clock and look at it from a position of partial information. The flow you feel is the statistical residue of your own incompleteness. The universe, looked at as it actually is, does not flow. It simply contains relationships. Things change with respect to other things. The pendulum swings while the earth rotates. The earth rotates while your heart beats. Your heart beats while the sun burns. There is no master clock all of these are timing themselves against. There is only the web of correlations. This is not a poet's interpretation. Rovelli's loop quantum gravity calculations work without any time variable at all. The math closes. The predictions hold. Physics at its deepest level functions perfectly without the river you thought you were standing in. And then there is Julian Barbour, who goes further. Barbour spent 40 years working as an independent physicist, refusing academic posts to keep his thinking unconstrained. In 1999, he published The End of Time, a book whose title is also its thesis. Barbour's claim is not that time is emergent. His claim is that time does not exist. At all. Anywhere. In any sense. What exists, he argues, is something he calls Platonia, an infinite, timeless landscape of every possible configuration the universe could be in. Each configuration is a complete frozen snapshot. He calls them nows. There is the now in which you are hearing this word. There is the now in which you were born. There is the now in which a star you will never see is exploding. They all exist. None of them is happening, they simply are. What you experience as the passage of time is, in Barbour's view, a kind of optical illusion produced by the fact that some nows contain records of other nows. The now in which you are hearing this sentence contains a memory of the previous sentence. That memory is part of the now itself. It is not evidence that the previous now was once present and is now past. It is just a feature of this snapshot, sitting in Platonia alongside every other snapshot. To grasp what he means, imagine a film reel. The traditional view of time is that the projector is running, and one frame after another is being illuminated, and the past frames are gone, and the future frames are not yet here. Barbour says, throw the projector away. The reel itself is all there is. Every frame exists equally, eternally, side by side. There is no light moving through them. There is no now. There is only the strip. You feel like the projector exists because each frame contains an image of someone holding a memory of the previous frame. But that someone is not moving through the reel. They are stationary, inside their frame, with a memory baked in. The next frame contains a slightly different version of them, with a slightly different memory. You are not one person passing through time. You are an infinite series of frozen people, each convinced they have just arrived from somewhere they have never been. If this sounds like a thought experiment with no consequences, it isn't, because in the last few years, the laboratories started catching up. In 2019, a team at the University of Vienna, led by Czeslaw Bruckner, ran an experiment on something called indefinite causal order. In ordinary physics, if event A causes event B, then A happens first and B happens second. The order is fixed. The experiment used a quantum device called a quantum switch, in which a single photon passes through two operations, A and B, in a quantum superposition of orders. Sometimes A before B, sometimes B before A, both at once. The result was not that we couldn't tell which came first. The result was that at the quantum level, there was no fact of the matter about which came first. Causality itself was in superposition. The experiment has since been replicated by independent groups in Hefei, in Brisbane, and in Vienna, again with different setups. In 2023, a team published results extending the work to entangled temporal orderings, where the sequence of events between two distant labs is itself entangled. Cause and effect, the bedrock of every story you have ever told yourself about your life, may not be fundamental features of reality. They may be, like time itself, statistical conveniences that emerge when systems get large and warm and noisy enough to fall into a single consistent narrative. Some critics, when these results came out, argued that this was just an artifact of the measurement, a quirk of how the quantum switch was constructed. The problem is that three independent teams in 3 countries using different photon sources and different geometries found the same thing. The superposition of causal orders is not a glitch in someone's apparatus. It appears wherever you look for it. So now stand back and look at what we have. An equation describing the universe with no time in it. A senior theorist arguing that time is an effect of our ignorance. Another arguing that time does not exist at all. And experiments in real labs showing that even cause and effect dissolve when you push hard enough on reality. This is not the picture of a few cranks at the edge of physics. This is the picture of a field that has spent 60 years quietly admitting that the most obvious thing about your life is the part it cannot find anywhere in its equations. Now sit with what that means, because the question we left open at the start has an answer, and the answer is heavier than it looked. If Ravelli is right, you are a thermodynamic creature in a timeless universe, and what you feel as the passage of time is the friction of your own incompleteness. If Barber is right, you have never moved at all. The you of 10 years ago is not gone. The you of 10 years from now is not waiting. They exist right now in the same way you exist, frozen in their own nows, complete and unreachable and absolutely real. Every moment of your life is still there. The morning you walked to school as a child. The evening someone you loved died. The ordinary Tuesday you forgot 10 minutes after it ended. None of them have gone anywhere. They have only stopped being the frame you happen to be in. It means nothing that has ever happened to you is truly gone. It means the people you have lost have not been erased. They are still there, in the nows where they were alive, in versions as solid and complete as the version of you sitting here now. It means the worst thing you ever did is still happening, somewhere in the frozen reel, and so is the best. It means grief and nostalgia are not failures of memory, but accurate intuitions, because what you are mourning was never destroyed. You simply move to a different frame, and from inside that frame the previous one looks gone. It also means you have already lived your death. Somewhere in the structure, the last frame of you exists. It is not coming for you. It is simply one of the configurations that is. From the perspective of physics, your birth and your death are not events at the start and end of a line. They are two of the countless nows that make up the full shape of you, and that shape, taken as a whole, is something timeless. You are not a candle burning down. You are a sculpture, complete, that you happen to be tracing with your attention one cross-section at a time. This is the part of physics nobody puts on a poster. Because if you take it seriously, even for a single evening, the architecture of how you feel about your own life starts to bend. The urgency loosens. The fear sharpens and softens at the same time. Loss does not become less painful, but it becomes less final. You begin to suspect that the strange, persistent intuition humans have always had, that the dead are not really gone, that childhood is not really over, that something of every moment remains. was never a comforting story. It was the residue of a truth physics had not yet caught up to. There is no comfort here exactly, only a different kind of weight. The river you thought you were standing in was never moving. You were never being carried away from anything. You were simply, in each instant, a complete and finished thing, briefly under the impression that you had somewhere to go. Wheeler died in 2008. DeWitt died in 2004. Ravelli is still writing, still calculating, still telling anyone who will listen that the clock on the wall is the last great illusion physics has to dissolve. Barber in his 80s is still in his cottage in Oxfordshire, still working on the structure of Platonia, still convinced that one day a young physicist will write down the equation that makes it undeniable. And you are here, in this now, with this sentence, with whatever you were carrying when you started listening. The universe, if these physicists are right, is not a story being told. It is a shape that exists. You're not a passenger on a train. You are a pattern in something that does not move. The moments you thought you had lost are, in the only language the universe seems to speak, still there. You just cannot reach them from here. The river was never flowing, you were never going anywhere, and nothing you have ever loved has actually been left behind.